Hello, calculus students. Today we're going to talk about inverse derivatives with a focus on trig inverses and how to take the derivative of an inverse function. So let's jump into this. First, let's remember how in the world you even find an inverse. If you remember, this is from swapping out the x's and y's. So if this is y, let's change this to an x equals 5, and then we'll replace the x with a y. So you swap the x's and y's, solve for y, and then that's the inverse. So if I add 1, and then I'm going to divide by 5, you'll get this crazy thing, y minus 2 cubed, and then we'll take the cube root of both sides and add 2. So let's just kind of jump to the final answer here. It would be cube root of x plus 1 over 5 plus 2, and then that all equals y. So this right here would be the inverse function of the original 5 times x minus 2 cubed minus 1. So again, the way we do that is we take an xy coordinate point and you swap the x and the y. So it's like this, you change them, and then this here would be the inverse if this is the regular function. Okay, so just a quick review on that. So now, here's some confusing notation that kids get mixed up quite a bit, and that is when we're used to seeing this -1 as an exponent, that just means it's 1 over x. You flip it, you make it reciprocal. But if you're talking about a function and you put a -1 with the function notation, it means it is the inverse. So this -1 and this -1 do not mean the same thing. You have to understand the context of the problem to know when it's talking about a reciprocal versus when it's talking about the inverse. Here is something that you'll see right on the front page of an AP exam. That is that when we're talking about trig functions, and we want to discuss specifically the inverse of a trig function, it could be written like this here, sine inverse of x, or you could be written as arcsine. These are interchangeable. So if you see them in some of the lesson here, some of the practice, you just got to think if you see arcsine or arctangent, it just means the inverse function of sine. So don't get confused when you're using the calculator. Here, if you're just plugging in a sine of x, that's just regular old trig function sine, and then 1 over sine, that is the same thing as cosecant x. Okay, that's 1 over sine versus sine inverse. This is the inverse of sine. This is not 1 over sine, which would be written here. And then 1 over sine inverse, this then, of course, would be the reciprocal function cosecant of x. So this is the inverse of cosecant if you say 1 over sine inverse. Okay, so with all of that quick reviews, let's jump into what in the world an inverse trig function is. Okay, these you just have to memorize. I'm sorry, you gotta memorize them. Write these down, and while you're writing, I'm gonna tell you some little secrets that I've kind of come up with that seems to help me, and it helps quite a bit of students, but you have to participate, so hopefully you're not gonna sound foolish by talking out loud. So, if you have one of these inverse trig functions that start with an s, so you see here you've got an s for the sine and an s for the secant inverse. If they start with s, that means you're going to have subtraction, and you're also going to have a square root. So s gives you subtraction, and s is also going to give you square root. So that's what you'll look for in these. Notice that in tangent inverse, it does not start with s. There is no square root, and there is no subtraction. In fact, it's addition. I also like to think of the t here. I didn't write this down, but the t is kind of looks like a plus sign, and so that helps me remember that this is the addition, or tangent is addition. Okay, so again, if it starts with an s, it is what? It has subtraction and square root. Okay, then the next thing is if you see sine, see how I can imagine a little number 1 here for sine, then it's going to start with the number 1. So here you have sine, 1 is first, and then we subtract x squared. Versus secant, it doesn't have that little I in there, so the 1 comes last. You have the x squared and then the minus 1. Tangent, because it is addition, it doesn't matter. You can put the x squared first or the 1. This would be the same thing if you said 1 over 1 plus x squared. It's commutative, so the addition doesn't matter which one comes first. Either one works. And then the last one, okay, sorry, this might be a little off color for some of you if you're a little sensitive. Sorry about that. C stands for, oh crap, there's an absolute value involved in this. So when you have the S, that's the subtraction and a square root, and then I have a C in there. Oh crap, there's an absolute value. You got to remember that thing. Okay, so let's cover this stuff up, and you need to quiz yourself on what these mean. Cover up this, in fact. Whoop. Okay, so I'm covering these up. Don't look down at your notes. If it starts with S, you're going to have what? A square root. Whoop. 1 over. You're going to have a square root and subtraction. And then which comes first? Since there's sign, that means the 1 comes first. Just like that. Okay, what about secant? So it's going to be 1 over, and then you have, it starts with an S, so there is subtraction, but it's not the I with the sign, so the 1 does not come first. The 1 comes last, and then you have x squared, and then secant. Oh, crap, there's an absolute value. Don't forget that thing. Put an absolute value in there. And then tangent does not start with subtraction, so we just have x squared plus 1, or you could say 1 plus x squared. All right, let's practice with this. So the derivative of sine inverse. So since it starts with sine, we're going to have 1 over. You have square root. I said subtraction. Square root. And then you're going to have subtraction. And which one comes first, the 1 or the angle here? It's going to be the 1 since it's sine. So we have a 1 here. And then normally we'd say x squared. But what is this here? It's a 3x. So it's going to be 9x squared. You square whatever that angle is. Now, technically, you have to use chain rule, so it's not done yet. Now you have to multiply by the derivative of the inside. So the derivative of 3x is just 3. So we could just then pull that 3 up to the top. Okay, erasing didn't work, so let's just put a 3. Get rid of that. So it's 3 over 1 minus 90 squared. There's our answer. Okay, next one. Tangent does not start with an S, so we don't have subtraction, and we don't have square root. So it's just going to be 1 plus or x squared plus, but we're squaring this whole angle. So that's going to be 4x to the 4th plus 1. And then it would normally be a 1 over, but we're going to multiply by the derivative of the inside to do the chain rule. So the derivative of the inside is 4x, and then that is our answer. Recognize that you cannot simplify this because you can only simplify if this was separated by multiplication. Since it's addition, this does not cancel. Okay, that is the answer. And number 3, here we're going to do a secant inverse. So if you remember secant, it also has subtraction. So let's do this 1 over. Now we have the absolute value of 5x to the 6th. And then we have the square root. So remember, the s is the square root and its subtraction. But it's not sine, so the 1 comes last this time, because the sine is the one with the 1 in front. And then here you do whatever this angle is squared. So that's going to be 25. So 5x to the 6 times 5x to the 6 is 25x to the 12th. And then the c is the, oh crap, you got an absolute value. And then we have to do chain rule. Derivative of the inside is going to be 30x to the 5th power. Now subtract 1. Okay, so how do we clean this up a little bit? We're going to have a 30x to the 5th up here on top and a 5x to the 6th on bottom inside the absolute value. So here's what we'll do. I know you don't have a lot of room on this, sorry. Let's go ahead and simplify. So what I'm going to do is say that the 30 and the 5 is going to simplify. So the 30 is going to become a 6. And then the x to the 5th is going to simplify with this x to the 6th. And there's going to be one x left. So hopefully you can see that. So let's go 6 over. And then we have x. Let's not worry about the absolute value yet. We'll figure out in just a second if we need it. And then inside here we have 25x to the 12th minus 1. Okay, this is really the most difficult part, is figuring out, do I or do I not need this absolute value? Here's what I would do to think about this. In the original here, you would have had, I'm going to write this down here on bottom, you would have had 30x to the 5th on top, and on bottom you would have had the absolute value of 5x to the 6th. With a square root of blah, 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 blah. Okay, so here's what you think about. If I were to plug in a -1, if x equaled -1, what's the sign? This would be negative on top. here, use blue, negative on top, and then you've got positive on bottom. That gives us negative, and a positive makes a negative. So as long as your final answer is going to also give you a negative, if you plug in a -1 right there, so think about that. If you take x equals -1, does this answer give you negative? Yes, it does. So you do not need the absolute value. If you had positive here, and you knew your final answer was going to be positive, then this would need an absolute value. Hopefully that made sense. You just kind of have to think a little bit about it before you simplified what was the answer if you need that absolute value. Here are the other half of the trig derivatives. So I want you to notice something. What we do is you take the CO version, which stands for complementary. I don't know if you knew that, but the C in cosine, cosecant, and cotangent all stands for complementary. It's an abbreviation. So the complementary versions of the trig functions are exactly the same as the originals without the CO, without the co, except they are negative. So each one of those just has the negative symbol in front, and then everything else is identical. So if we're taking derivatives and it starts with C, that is the negative version of the original inverse trig. Okay, so pause and write that down if you don't have everything down right now. Okay, the next part is, for the first time this year, we're going to talk about something called an antiderivative. Now that doesn't mean anti as in we're against something. We're not against the derivative, but it's just taking the opposite of the derivative. So we will talk a lot more about this when we get to units probably 9 and 10. We'll do a lot more with these inverse trig, but I want to help you understand a little now, because this is really what you're going to typically see on an AP exam, and that is, if you had the derivative, what in the world would the original thing be? So what would the original function be if this was a derivative? So a possible original function, if we took the antiderivative, worked backwards, since it has a square root, this is going to be starting with an s. And since the 1 came first, it is sine. So sine inverse of, okay, so this is the tricky part. If this is what the x squared is, what is the square root of 36x to the 4th? The square root of that is 6x squared. So this is probably a 6x squared, and then we can check by seeing if the chain rule was in effect. So what's the derivative of 6x squared? That would be 12x. So you can see here, this works. If you take the derivative of sine inverse of 6x squared, it gets you this thing, because the chain rule would then be 12x on top. Now that's probably a little confusing because you have not had to do antiderivatives yet. Now technically we could also have any number we wanted. So we could have like a +2 or a +0 or a +3 or a +4 and so forth. It could be anything, because if you take the derivative of a constant, you have 0. So what we're going to say in this case, just to be consistent, I know this is jumping way ahead into units 8 and 9, but we are just going to say that this could be plus any constant we wanted. Okay, so if I give you the derivative and I'm asking what's the antiderivative, you find the original inverse function and then just put a plus c, because there could be any constant there we wanted. Very last part of our lesson now. Here we go with the derivative of an inverse function. Now this is not a trig inverse. This is just a general function. If we had its inverse, how would we take its derivative? So here's the formula. It's going to be 1 over f prime. So the derivative of the original function with the inverse plugged in. Let me say that again. You're going to take the derivative of the original function and plug in the inverse. And then, of course, it's the reciprocal, so 1 over that. So how do we do that? Here I've got an example. So if we need to take f prime, we've got to figure out what f prime is. So I'm going to take f of x, take its derivative, and we'll come up with negative sine x minus 6. Okay, this is important. You absolutely must get the derivative first in order to do this. What else have we got? So we also need to know the inverse, and in this case, at a specific value of negative 9 pi. Well, I gave you that already. I told you that f inverse of negative 9 pi equals 3 pi over 2. So what we're going to do, let me write this down here so you can kind of tell. I'm going to take the fraction 1 over f prime of, now what's going to go inside here? F inverse. So I'm going to put f inverse of what? of negative 9 pi. So negative 9 pi. Squeeze that in really small there. And okay, so what does that equal? 1 over, I'm trying to go step by step so this doesn't confuse you. 1 over f prime of, what is f inverse of negative 9 pi? F inverse of negative 9 pi is 3 pi over 2. See, I gave it to you. It's right there. And then that's going to equal, so what is this? It's going to be 1 over, okay, now in order to know this, you have to know what f prime of 3 pi over 2 is. So I'm going to, I guess maybe I could squeeze that in right here. F prime of 3 pi over 2 is going to equal negative sign. Okay, I ran out of room, so I'm going to move it, which you can't do on your paper. So you're like, dang it, Mr. Bean, and now you're erasing. Well, I'm doing this negative sign of 3 pi over 2 minus 6. What is that? 3 pi over 2. So that is going to be negative 1. So I have negative 1 minus 6. So negative 1 minus 6 is negative 5. So my answer then is negative 1/5. Box my answer. Okay, so last problem here. This is a little different, and by the way, I'm sorry here, I scribbled this out because I had something else. Your notes will be right. It'll have an x equals 4 in your packet there. So we're going to now take the derivative. What we've got to do, of course, is, or the derivative of inverse. So we are going to, one of the things we're going to need to know is we'll have to know the derivative. So f prime of x is going to equal 2x. That's simple enough. And then what else do we need to know? We're going to have to figure out f inverse of 4, because we want to take it at an x value of 4. What in the world is that? How are we supposed to do that? Well, you can just switch variables here, make this an x, make this a y, solve. And if you do that, you're going to get y equals plus or minus the square root of x. Okay, so then we could plug in a 4 here, and you're going to get plus or minus 2. So how do we know which one to use? Because really, if you plug this in, you see what I'm saying? It could be plus or minus 2 if this is the inverse function. Well, it might be either one. It depends on which coordinate point we're working with. So we're going to make this really easy for this assignment. If you ever have this situation for this practice, I'm just going to stick with the principal root. Okay, the principal root is the positive root. So we're just going to stick with the positive one and just say 2. So another way of thinking of this is this. Sometimes this might make it easier too. It's the same thing as saying if you took the original function, how can you make this be a 4? If you plug in a 2, you get a 4. So if you do the inverse of it, then that might lead you to this. So these are the two main important things that we need. I'm boxing it not because it's the answer, but I want to focus on that. Okay, so let's set this up. We go 1 over f prime of f inverse of, what are we doing? X equals 4. And then I probably, parentheses bracket, it's the same thing. So then I say 1 over f prime of, what's f inverse of 4? F inverse of 4 is 2. So it's f prime of 2. And then so we get, this is equal to 1 over, what's f prime of 2? You plug a 2 into f prime, you get 2 times 2 is 4. 1/4. There you go. That's it. Okay, we've covered now everything dealing with the inverse functions for derivatives. Good luck working through this packet and rock that mastery check.